Hi, everyone. Thank you for joining me for our last lecture of the course. It has been an amazing ride, and I'm happy to be here. Today's session is designed to bring everything we've learned this semester full circle. First, we'll dive into how NLP and AI are being applied across industries, showing you how the concepts you've mastered are used to solve real-world problems. From chatbots to recommendation engines, NLP is everywhere, and understanding its applications will help you appreciate its power and versatility. We'll also address some of the challenges of implementing AI systems responsibly. Ethical considerations like bias, privacy, and misinformation are critical topics, and we'll discuss how developers and organizations are working to mitigate these risks. Finally, we'll reflect on your chatbot project, revisiting how the techniques you've learned come together in practice. Let's begin by exploring NLP's impact across key industries. Section 1. Practical applications of NLP and AI. NLP has revolutionized several industries by automating processes, extracting insights from data, and enhancing user experiences. In healthcare, NLP systems help with clinical trial analysis and power patient-facing chatbots. These bots assist with triaging symptoms, scheduling appointments, and providing medication reminders, easing the burden on healthcare providers and improving patient accessibility. In finance, NLP is used for fraud detection by analyzing transaction patterns and identifying anomalies. Market sentiment analysis is another significant application. By evaluating news articles, social media, and financial reports, NLP tools provide insights that influence investment decisions. Meanwhile, e-commerce platforms rely heavily on recommendation engines and chatbots to provide personalized shopping experiences. These applications demonstrate the versatility of NLP across domains, but to better understand its depth, let's examine a specific use case. Grammarly is a powerful example of how NLP enhances everyday tasks. It uses AI to analyze written text, offering suggestions to improve grammar, tone, clarity, and style. At its core, Grammarly employs parsing to break down sentences into grammatical components. For example, it can identify the subject, verb, and object of a sentence to ensure proper syntax and agreement. Beyond syntax, Grammarly uses a machine learning model, S, trained on massive datasets of text to predict and recommend more natural or effective phrasing. Additionally, its intent recognition feature tailors suggestions based on the context of your writing. For example, Grammarly can adjust its recommendations for a formal email versus a casual message. This functionality is why Grammarly is trusted by over 30 million users daily, illustrating how NLP tools can profoundly impact productivity and communication. Now, let's turn our attention to the ethical implications of building such systems. Next, we will jump into Section 2, Ethics of NLP and AI. Ethical challenges in NLP and AI are significant and must be addressed as these technologies continue to grow in influence. One of the most pressing issues is bias, which occurs when models trained on historical data reflect and amplify societal stereotypes. For example, an AI hiring tool trained on biased historical data might favor male candidates over equally qualified female applicants, perpetuating workplace inequality. Another concern is of privacy. Many NLP applications, such as chatbots and virtual assistants, handle sensitive user data, ranging from financial information to personal conversations. If this data is not adequately secured, it could be misused or exposed in data breaches. Transparency is another critical issue. Users often don't understand why AI systems make specific recommendations, which can lead to mistrust. Finally, misinformation generated by AI models can spread false narratives with harmful implications for society. These challenges highlight the need for responsible AI practices, which we'll discuss next. While NLP systems offer numerous benefits, they can also lead to unintended consequences. One concern is over-reliance. As NLP systems become more accurate, users may trust their outputs without question, even in high-stakes scenarios. For example, a misinterpreted medical chatbot recommendation could delay critical care. Another issue is the amplification of bias. If unchecked, biased models can exacerbate existing societal issues, such as reinforcing stereotypes in hiring or housing. For instance, a language model generating biased content in loan approvals could systematically disadvantage certain demographics. Finally, automation enabled by NLP, such as in customer service and translation, raises concerns about job displacement. While these systems improve efficiency, they also highlight the need for reskilling programs to support affected workers. Addressing these issues requires foresight and proactive measures. Legal and regulatory challenges present significant obstacles in deploying NLP systems responsibly. A major concern is ambiguity and AI liability. If an NLP system makes a harmful decision, such as an incorrect medical diagnosis or defamatory content generation, who is held accountable? The developer, the organization, or the user? Another challenge is the lack of global standards. Regulations like GDPR in Europe address data protection, but such frameworks aren't universally adopted, leading to inconsistent oversight. This discrepancy creates gaps in accountability and enforcement. Finally, data ownership raises ethical questions. For example, who owns the rights to the data used to train models, especially when sourced from publicly available information like social media? These issues underscore the need for robust legal frameworks and international cooperation to ensure ethical and responsible NLP use. As AI becomes increasingly integrated into our daily lives, human dependency on these systems is growing. From virtual assistants like Siri and Alexa to complex medical diagnostic tools, AI is designed to enhance efficiency and support decision-making. However, it's important to emphasize that AI is a tool, a collaborator meant to assist humans, not replace them. For example, AI can handle repetitive tasks like data sorting, freeing humans to focus on more creative or strategic work. Despite these benefits, fear of AI remains prevalent, often fueled by misconceptions and sensationalized portrayals in media. Concerns about AI taking over jobs, becoming uncontrollable, or even surpassing human intelligence contribute to this anxiety. But it's crucial to understand that AI systems are programmed to operate within boundaries set by human developers. AI doesn't possess intentions. It executes tasks based on its training and design. Educating people about AI's capabilities and limitations can alleviate these fears. By framing AI as a partner in solving complex problems, from predicting natural disasters to advancing medical research, we can foster a mindset of collaboration and trust. AI is here to amplify human potential, not diminish it, and our focus should remain on ensuring its responsible and ethical use. To address ethical risks, organizations must take proactive steps. Bias auditing involves reviewing datasets and models to identify and mitigate biases. Techniques like rebalancing training datasets and employing adversarial debiasing algorithms can reduce inequities in AI predictions. For instance, ensuring equal representation of genders and ethnicities in training data can prevent biased outputs. Data privacy must also be a priority. Measures such as encryption, anonymization, and strict access controls protect sensitive information. Additionally, fostering transparency is critical for building trust. Explainable AI tools like Lime and SHAP help users and developers understand how a system arrives at specific decisions. Finally, maintaining human oversight in critical applications, such as medical diagnoses or financial approvals, ensures that AI complements human expertise rather than replacing it entirely. These steps are essential for deploying NLP systems responsibly. Next, we will discuss some future trends in NLP and AI. The future of NLP is being shaped by several transformative trends. Large language models, LLMs like GPT-4 and BERT, are pushing boundaries in understanding and generating human-like text. These models demonstrate impressive fluency and accuracy across various tasks, from summarization to creative writing. Another exciting development is multimodal AI, which integrates text, images, and audio for richer interactions. For example, DALL-E generates images based on textual descriptions, combining computer vision and NLP. Lastly, low-resource NLP addresses the need for models that work in underrepresented languages. Innovations in transfer learning and multilingual training are helping bridge the linguistic gap, ensuring AI benefits are more inclusive globally. Let's now discuss tools and resources to stay ahead in this evolving field. To continue your NLP journey, leveraging the right tools and resources is essential. Libraries like Hugging Face offer pre-trained models and pipelines for tasks like text classification and summarization. Frameworks like TensorFlow and PyTorch provide the flexibility to develop and train custom models for advanced applications, and data sets allow you to practice real-world applications, while online courses on Coursera and edX can deepen your understanding of specialized topics. For experimentation, datasets like Europarl for multilingual tests and Esquad for question answering are excellent resources. These tools will empower you to build on what you've learned and tackle increasingly complex NLP challenges. Lastly, we will reflect and wrap up the course with future information. Throughout this course, we've covered essential NLP topics, from foundational concepts like parsing and part-of-speech tagging to advanced applications like machine translation, clustering, and chatbots. Your chatbot project allowed you to integrate these techniques into a functional system. For example, you may have used vector space models for intent classification, dialogue management to maintain conversation flow, and NLU techniques to generate meaningful responses. This project not only demonstrated your ability to apply theoretical knowledge, but also prepared you to handle real-world challenges in NLP. Once again, thank you so much for an amazing semester. I hope to see you all in my future courses. As a wise man once said, stay hungry, stay foolish.